11 million light years away, there's a galaxy that shouldn't look the way it looks. Its shape is wrong. Its structure is wrong. A thick, twisted lane of dust cuts straight across its middle like a scar, and buried inside that dust, hidden from every telescope that relied on visible light to study it, sits a supermassive black hole firing jets of superheated plasma out into space at speeds that would make anything caught in their path simply cease to exist. For decades, astronomers have known this galaxy is strange. They've known something violent happened here. What they haven't had, until the second week of July 2026, is a clear enough look inside it to actually understand what that violence left behind. Then, NASA, in partnership with the European and Canadian space agencies, released a set of images to mark 4 years since the James Webb Space Telescope's first pictures were shown to the public. And buried in that release is a structure so strange that the scientists who found it are openly admitting they don't yet know what created it. This is the story of what Webb just captured at Centaurus A, the questions its new images answered, the one they couldn't, and why NASA is calling this look inside the galaxy unlike anything any telescope has managed before. I'm your host, and this is your channel. If you want the real story behind the most incredible images coming out of space right now, subscribe now, because we're just getting started. To understand why this specific image matters so much, you first need to understand what Centaurus A actually is, and why it's been a genuine puzzle to astronomers for a very long time. It sits roughly 11 million light years from Earth, which sounds unimaginably distant until you realize that, on a cosmic scale, this makes it one of our closest large galaxy neighbors, practically next door in astronomical terms. Under normal circumstances, a galaxy this close should be relatively easy to study in detail. But Centaurus A isn't a normal galaxy. Roughly 2 billion years ago, it collided with another galaxy entirely, a genuine cosmic collision, one galaxy slamming into another under the relentless pull of gravity over millions of years. That merger didn't destroy either galaxy outright, but it permanently reshaped what was left, dumping an enormous supply of fresh gas and dust into the resulting structure, material that has been fueling intense, ongoing star formation ever since. It also fed something far more dangerous, the supermassive black hole sitting at the very center of the galaxy, which found itself with a fresh, abundant supply of matter to consume. As that material spirals inward toward the black hole, it doesn't vanish quietly. It heats up to extreme temperatures and gets funneled into what astronomers call an active galactic nucleus, a bright, violent central region that blasts twin jets of high-speed plasma outward from the galaxy's core, visible even from Earth in radio wavelengths, which is part of why Centaurus A has been one of the most closely studied galaxies in the southern sky for decades. The problem has always been actually seeing what's happening at the heart of all that activity. Centaurus A's central region is wrapped in thick, dense lanes of dust, material left over from that ancient galactic collision. And dust like this is extraordinarily good at blocking visible light, the kind of light our eyes see and the kind the Hubble Space Telescope has traditionally relied on for most of its observations. For years, Hubble could photograph the outer structure of Centaurus A beautifully, but the actual engine driving the galaxy's strange behavior, the region immediately surrounding that central black hole, remained essentially hidden behind a wall of cosmic dust that visible light simply could not penetrate. NASA's Spitzer Space Telescope, retired in 2020, took an earlier attempt at solving this problem using infrared light, which can pass through dust far more effectively than visible light can. Spitzer's observations were a genuine step forward, allowing astronomers to resolve some of the larger structures buried inside that dust for the first time. But Spitzer, for all its contributions, simply didn't have the resolving power to pick out individual stars or fine structural detail. It could tell you something was there. It couldn't show you clearly what that something actually looked like. That's exactly the gap the James Webb Space Telescope was built to close, and the new images released in July 2026 demonstrate precisely why. Using its two primary infrared instruments together, the near-infrared camera, known as NIRCam, and the mid-infrared instrument, known as MIRI, Webb was able to cut through Centaurus A's dust lanes in a way no previous observatory had ever managed, revealing what NASA describes as a densely packed tapestry of individual stars, along with the active, ever-changing structure surrounding the galaxy's core. Sean Donegal-Goldman, the division director of astrophysics at NASA headquarters in Washington, put the broader significance of this kind of observation plainly in NASA's official announcement. "No single telescope tells the whole story," he explained. "Discoveries build over time, and new observatories expand on the foundations laid by earlier missions. Webb," he said, "represents the most powerful step forward yet, opening a window into wavelengths and details never before accessible, allowing astronomers to examine structures and processes that previous telescopes simply couldn't see." That's not a small claim. It's a direct statement that this specific image represents a genuine leap in what humanity can actually observe about one of our nearest active galactic neighbors. And the details Webb pulled out of the dust are genuinely remarkable. In the combined near and mid-infrared imagery, NIRCam data reveals a dense field of millions of individual stars packed into Centaurus A's structure, resolved with a level of clarity that neither Hubble's visible light instruments nor Spitzer's earlier infrared observations could achieve. Meanwhile, MIRI's data revealed something else entirely: glowing stellar nurseries, regions actively giving birth to new stars, releasing gas and dust into their surroundings as they form. Webb's data also allowed astronomers to directly trace fast-moving ionized gas being violently pushed outward by the activity of the central black hole, along with warmer molecular hydrogen arranged. In a warped, rotating disk close to the galaxy's core, direct physical evidence of exactly how a supermassive black hole reshapes the material immediately surrounding it. Scientists have long theorized that a galaxy's central black hole can play two seemingly contradictory roles in that galaxy's evolution. On one hand, by condensing surrounding gas and dust, an active black hole can actually trigger intense bursts of new star formation, essentially acting as a catalyst for galactic growth. On the other hand, the same violent activity, the same superheated jets and blasted out ionized gas, can eventually purge a galaxy of the very raw material it needs to keep forming new stars at all, effectively starving the galaxy and slowly shutting down its ability to build anything new, a process some astronomers describe starkly as the black hole killing its own host galaxy over time. Centaurus A's new Webb data appears to show clear physical evidence of both processes happening simultaneously in the same galaxy, which gives researchers an unusually direct close-up laboratory for studying exactly how this dual role, creation and destruction, actually plays out in real galactic structures, rather than just in theoretical models. But here's the part of this discovery that hasn't been fully explained yet. The piece that NASA itself has openly acknowledged remains genuinely unresolved. Buried within the new MIRI imagery of Centaurus A, alongside all of those clearly identifiable stellar nurseries, sits a distinct S-shaped structure, a feature with a specific, recognizable geometric form that doesn't obviously match the more chaotic, irregular patterns typically produced by ordinary star formation or dust distribution. According to NASA's own statement accompanying the image release, scientists still don't know exactly how this C-shaped structure formed, and they don't yet know whether the galaxy's active central black hole played a direct role in creating it. This isn't a minor footnote buried deep in a technical paper. It's a genuinely open question, sitting right in the middle of one of the clearest images ever taken of this galaxy. And it's exactly the kind of unresolved mystery that new, more sensitive instruments tend to produce. The closer and more clearly you look at something, the more new specific questions tend to appear alongside the answers you were originally looking for. This new look at Centaurus A didn't arrive in isolation. It was released as part of a broader set of images NASA, the European Space Agency, and the Canadian Space Agency put together specifically to mark 4 years since Webb's first full-color science images were shown to the public back in July 2022, an anniversary that effectively kicked off what astronomers have since described as an entirely new era in observational astronomy. Alongside the Centaurus A images, the same July 2026 release included a striking new look at Messier 82, also known as the Cigar Galaxy, a much smaller galaxy than our own Milky Way that is, despite its size, 5 times more luminous and forming new stars roughly 10 times faster than our galaxy does, making it one of the most intense starburst galaxies in our cosmic neighborhood. In visible light, the core of M82 has always been obscured by its own thick, dusty clouds, much like Centaurus A. Webb's NIRCam instrument was able to draw back those clouds entirely, revealing the full brilliance of the galaxy's central region and resolving approximately 16.5 million individual stars within it, a combined view built by pairing Webb's near-infrared data with archival visible light observations from Hubble, giving astronomers their most complete picture yet of exactly what's driving M82's extraordinary burst of star formation, likely triggered by its ongoing gravitational interaction with its larger spiral neighbor galaxy nearby. Taken together, these anniversary images represent something bigger than just 2 pretty pictures of 2 interesting galaxies. They represent a genuine, measurable 4-year track record of a single instrument fundamentally changing what's observationally possible in astronomy. Since its first images were revealed in July 2022, Webb has been used to study everything from the earliest galaxies in the observable universe to the atmospheres of planets orbiting other stars, to the birth of new star systems inside our own Milky Way, all using the same basic underlying advantage on display in these new Centaurus A images, the ability to see clearly through dust and gas using infrared light that no previous space telescope could gather with anywhere near the same sensitivity or resolution. NASA's own framing of this anniversary emphasized that Webb doesn't operate in isolation, that its discoveries build directly on decades of earlier observations from Hubble, from Spitzer, from ground-based observatories around the world, expanding on those existing foundations rather than replacing them outright, and revealing what NASA describes as processes and structures that simply weren't visible to any instrument that came before it. What makes this particular anniversary release genuinely compelling, rather than simply a routine celebratory image drop, is that combination of clear, demonstrated success alongside honest, acknowledged mystery. Webb didn't just confirm what astronomers already expected to find at the heart of Centaurus A. It resolved millions of individual stars for the first time, traced the physical mechanics of how a supermassive black hole reshapes its surrounding galaxy in real observable detail, and then, in the same dataset, handed researchers a completely unexplained structure that doesn't yet fit cleanly into any existing model of how this kind of galaxy is supposed to behave. That's not a telescope simply confirming old theories with better resolution. That's a telescope actively generating new, specific scientific questions that didn't exist before this observation was made. Questions that will now shape follow-up research and future observing time for years to come. 4 years into its operational life, performing, in NASA's own words, better than anticipated the entire time, Webb continues to demonstrate that even our closest, most extensively studied galactic neighbors still have genuine secrets left to reveal, provided you finally have an instrument capable of actually seeing through the dust that's been hiding them. If this kind of story is what you come here for, one grounded in what NASA actually released and actually said, rather than exaggeration, hit subscribe and turn on notifications, because there's a lot more of the universe left for this telescope to reveal. Drop a comment telling me what you think that mysterious S-shaped structure at the heart of Centaurus A actually is, and share this with someone who still thinks we've already seen everything our nearest galactic neighbors have to show us.